everyone. Thanks, folks, for coming and listening. Let me just share my screen. And there we go. Okay. Um, so this session is about environments, and environments are one of those things, or pre-production environments in particular, are one of those things where I think we're all very experienced with them. We all use them in our organizations, routinely as part of our SDLC, our process for getting code live. But like many things, the sort of agentic coding wave has kind of sort of forced us to call these things back into question again, how we're doing them and how we're using them. And environments we think are one of those sort of critical components and sort of set of processes around which we need to kind of revisit our thinking in order to really take advantage of Gen AI. There we go. Right. So just to sort of set the scene, this is, I guess, the sort of the common environment setup that I'm sure many of you, have or will have experienced. Certainly, I've seen this a lot in my career. Essentially, each of these blue boxes is a replica of live, a full replica with a bunch of running services in it. And when we make a code change, typically it kind of flows from left to right, and we do different kinds of testing at the different stages, and hopefully that change goes live. And some organizations do this version of it. If your engineering org is quite large and there's lots of contention around environments, then we do this, which is can be very expensive, can be very sort of operationally intensive, and all of this kind of thing. And I would say this approach is kind of has sort of served us tolerably well up until now. Arguably, a lot of organizations doing microservices and cloud native development have already started to struggle with this model of environments and look for alternatives. But I think a lot of organizations have kind of just about muddled through. Um, but this is the proposition for today, is that this model of working with pre-production environments is just not fit for purpose anymore in the kind of agentic coding era. And I'm going to go through a few reasons why. So the first is probably the most self-evident one, I think, at this point, which is that if we're producing 10 times more unverified code, then unless everything downstream from that code, between generating it and production, is also 10 times faster, then we're not going to deliver 10 times more features to our customers. What we're actually going to do is just pile up 10 times more work in progress in front of our testing column in our Kanban board or whatever we're doing, which is not really what we want. So although there's a whole load of stuff that typically happens kind of downstream of generating code, a lot of the excuse me, a lot of this stuff happens in a pre-production environment of some kind, and how those environments are built and how they're used and how they're operated can have an enormous effect on how much throughput of change you can get through them. So this is really important. Second thing is around sort of flakiness and determinism. If you have environments that are kind of are either non-deterministic or flaky, and you've got human beings testing in them, then they can kind of work around these things. But with AI, the consequences of these things can be much more severe. AI tools will misinterpret flakiness as problems with code. They'll go and rewrite perfectly good code. They'll hallucinate bugs that don't exist and try and fix them. So if we want to make our kind of agentic workflows work well, then flaky environments are a really big problem and something that we want to eliminate as much as possible. And then the third thing has to do with building AI-driven applications specifically. So the previous 2 points were about using AI in our SDLC, but still kind of building classical software. If you're building something like an agent, your own agent or something of that kind of flavor that has an LLM in the middle of it, then there's this whole new sort of style of testing that you probably have to incorporate into your workflow, known as evals. And this is essentially about using an LLM as a judge, to sort of run a test against an LLM-driven application and then judge the output and score it. So two things about this. One is that it's a very non-deterministic process anyway. It's LLM driven, so inherently there's a lot of variability to it. And what we don't want is for the environment to create additional variability, either through sort of random errors or just through non-determinism, through variation in data or results, because that can confound the testing that we're doing and bias it or reduce its usefulness. So we need this clean room, which is essentially a very reliable, very deterministic environment in which we can do this kind of stuff. And secondly, we need very high parallelism for this if we're going to do it at all at scale, because an eval takes a very long time to run, far longer than a classical test. So if we want to do significant numbers of them, then we need to do a lot of them in parallel. And that changes our environment needs somewhat when you pair it with the need for these environments to be kind of isolated and totally deterministic. So those are our reasons. So in summary, we want we want our environments to be all of these things. I've kind of listed observable on there. I haven't really talked about this yet, but I think the another aspect of working with agents, which is important, is that the more context they have, the better they can be. So if you are performing a test on something, you need to be able to examine the impact that your test had on the environment as part of the of checking whether it's actually correct or not. So if you're in an environment where it's difficult to see the consequences of an action, then that's also not good. So we want all of these things, and we want abundant, cheap, fast to spin up, fast to get rid of environments. Um, and then we can raise our throughput massively. We can test deterministically and avoid having to rescue our agents from flakiness and all of that kind of thing. Um, So just to sort of dig a little bit deeper before we get into the practical part of it, I want to sort of talk about the specific effect of how environments are constructed, and I'm going to talk a little bit about API simulation and how this is a key part of the solution in our view. So this is kind of zooming in on one of those kind of classic environments. So this is where you have a sort of complete replica of your live environment essentially. And in a lot of places, it kind of looks like this. So you have your modern sort of microservice based stuff where you're probably doing most of the work to change these things currently. This is where the active development's happening. But then you have legacy systems as well, and these might be old systems that you've built on old technology, or they might be bought products. And whereas your microservices are kind of easy to spin up and run and configure differently and so on like that, legacy systems maybe not so much. It might be that you have hardware restrictions or licensing restrictions, or the system architecture makes it very difficult to kind of partition them up or create new environments. So legacy systems can be a real sort of constraint on being able to create more environment capacity in that regard. Third-party APIs, the purple ones on the right, similarly, they, uh, third-party systems sometimes have bad sandboxes or no sandboxes, or they're very restricted in the data you can put in there, or you can only have a small number of them, so the degree of isolation you can get is very low. So a lot of the same problems exist that mean that sort of scaling environment capacity efficiently is very difficult. Um, so that's kind of our starting point. This is what we want to get away from a bit. Before we get into that, let's just talk a little bit about API simulation a bit. I mean, I'm sort of hoping that most of you have a kind of general idea about API mocking, API simulation, and what it means. But just in case there's anybody who's not so familiar with the concept, essentially it's this. So you have a one service talking to another one via an API. So client A talking to client B talking to service A via its API. And all we're doing is we're substituting service A for a simulation of its API. So we're saying we're going to make something that walks and talks exactly like the API for service A, but where we can control exactly its outputs, and we can change it at will, and we can run it very cheaply and so on like that. And we're going to drop it in as a substitute in a way where client B doesn't even really know that anything's changed. So that's the simulation in a nutshell. Obviously, there's a lot more to it, which you'll see later in the demo. But conceptually, hopefully, this is all you need at the moment. So let's get back to our environment diagram. So now that we've got the ability to simulate APIs, this is something we see a lot of our customers doing, and ones who have sort of smaller, maybe earlier microservice architectures. They will, quite commonly substitute out all of those nasty dependencies, the legacy and the third-party APIs that are particularly problematic for them. So once they build simulations of these, those simulations can be cheaply copied, many replicas made. And that means that they can scale out their microservice testing. They can have many more copies of these environments with these microservices plus simulated external dependencies. So this is a big improvement. This is something that allows you to do more in parallel, to get more work done, and to reduce the flakiness, the non-determinism, the poor performance, and everything else that comes from those third-party and legacy systems. So we can go further than that, though. We can, rather than running our whole microservice systems together, which also becomes kind of untenable as your number of services grows beyond a certain point, we can start isolating smaller chunks of our system. We can say, I want to test these, pairs or small sets of collaborating services together, and then create this boundary of simulated services around that. So you're kind of saying these are the things where I run the real thing. These are the things I care about testing. This is the actual functionality I'm testing. Everything outside of that, I'm just kind of using it to create assumptions and preconditions for those tests. And likewise, you can go all the way in and you can say, I'm just going to test a single component, and I'm going to simulate all of its external dependencies. And obviously, the further down this scale you get, the smaller and faster and cheaper to maintain, these environments become. They gain more and more of those properties that we talked about earlier of kind of desirable environments. Um, and from this, I would say that one size doesn't fit all. All of these are kind of valid environment configurations, and the key thing is to be able to be flexible and to design environments that fit the testing goals that you have. So uh, yeah, not throw all of your testing workload at one big shared environment that's a replica of everything, but kind of choose the right combination of services and simulated APIs that's going to get the testing job that you want done in a focused way. Um, and I'm sure this is what you're thinking, is that sounds like a lot of work. But this is also where AI, sorry, can come to our rescue as well. So it turns out that AI is very good for building API simulations. It's great for the kind of a lot of it is grunt work. A lot of it is transcribing a piece of documentation or some other description of an API into a simulation. And AI tools are very good at doing that sort of thing and very, very good at automating that kind of thing efficiently. Um, so that's what I'm going to talk a little bit about next, and then we're going to go into the demo. Um, the Obviously the important thing with whenever you're working with AI is that you can always get it to generate something plausible looking, but really we want to make sure that we generate something that we've validated in some way that we can trust. Beyond being given, Claude Code giving its word to us that it's all good, that we've actually got something which is, in this case, faithful to the existing API. Um, what we've found and what we've been embedding into our tooling around WireMock Cloud is that sort of separating generation, verification, and enhancement, and sort of mixing these approaches together in sort of structured workflows can produce substantially better and more reliable output than just kind of doing one shot generation. So, generation can be sort of, doing it the old way, the deterministic or AI based. So you can use imports or recording to do generation, or you can use a coding agent sort of straight off the bat. Um, Likewise, verification can be both, sort of deterministic and eval style. So you can do contract testing in a variety of deterministic ways, which I'll get into in a moment, and to ensure the API maintains contract consistency, but also you can do eval style testing to look at more sort of what we would think of as kind of qualitative properties of your simulated API. And then finally, progressively enhancing the realism of an API is a good way to go as well. So starting, for instance, with something stateless with a bunch of sort of sparse static stubs, which are correct, but maybe, like I say, not very dynamic, not very flexible. But then incrementally improving, upon that to add statefulness, to add maybe, dynamic manipulation of dates, to add, making it data driven, that kind of thing. leaning on your verifications to support that is a good way to work. So diving in very quickly. So it's one other thing it's worth saying is that the it's when you're doing this, then you need to go and sort of gather your sources of truth for the APIs that you're simulating. So all of these things on here, obviously all of them can vary in quality. I mean, if you've got the source code for the API that you're simulating, this is probably the best source of truth available. Machine readable documentation, if there are some great open APIs which companies use as a key part of their documentation workflow. In which case, great, use them. But if sometimes there are some terrible, vague, out of date and outright wrong open APIs out there. So you need to apply some judgment about this. But all of these things taken together can be useful in these workflows. So looking at what we can do specifically very quickly. Generation's pretty straightforward. You can tell your coding agent, here's an open API description, here's a Postman collection. Go and build me a simulated API. And in the case of WireMock Cloud, you can use our MCP server and our agent skills, and it will go and directly build you an API simulation in WireMock Cloud. Verification. So again, WireMock Cloud has this notion of contract testing via OpenAPI. So you can feed test requests through to your simulated API with validation switched on, and if anything doesn't comply with the contract, then this will come back both in the request log and in the responses, and then your coding agent can use that information to go and fix the simulated API, essentially to correct it. So you can make it loop on this, and eventually it will converge on something which is compliant with the contract. If you don't have a good open API description, another way you can achieve this is via a vendor SDK. So if the provider of an API has put out a vendor SDK that you think is battle tested, then you can ask your coding agent to generate some tests that are driving your simulated API through that vendor SDK. And then again, you can keep running this in a loop and saying, run all these tests, keep fixing the API until the test had passed, and then only tell me the simulated API is good once you can make these tests pass. And then final slide before I hand over to Dan, you can put all these techniques together and you can do something a little bit more elaborate. And this is I've added one extra sort of step in here as well. So this is using, if you have an existing test suite for your application under test, then you can use this to drive traffic to a real API through WireMock's recorder, and you can record an API. So this is kind of an example of generating, in a non-AI way. You're essentially capturing real traffic and you're sort of mapping it one to one to stub responses in WireMock Cloud. But what you can then do if you want, so I talked about using enhancement to kind of provide extra realism, whether it's statefulness or making it data driven or whatever. You can still ask your coding agent, go and look at the simulated API, but generalize it, make it stateful, and then run my validation loop in the same way as I did before to ensure that the enhanced version is still contract compliant. And I can do this incrementally. I can record part of an API, and I can go through this enhancement loop, the validation loop, and then later on I can come back and record another part and so on like that. And I can use this to evolve, to maintain my API as it evolves over time, because this is a very important thing, is that the real API and the simulated one will drift over time, and having a regular process you can run to keep the two in sync with each other is really important. And I think that's about it with the conceptual stuff. So I'm going to hand over to Dan now, who is going to give you a live demo that will hopefully kind of bring all this to life for you.
Thanks, Tom. Hey, everybody. Dan here. I'm going to kill my video for the rest of the demo here to save a little bit of bandwidth as I'm on a slower connection. Just wanted to make sure that you knew I was here in person. So let me do that first, get my screen shared, and we'll get going. Okay. So first, I'll show you the little bit of code that I had AI create for us. So we're going to be working with the Stripe API today. And I used AI to create a small microservice, the product microservice here, a couple other microservices, but we can see on the left-hand side that this is indeed going to be using the Stripe SDK for Node when we actually deploy this into production. And then as part of that code generation, AI also created the test suite for me. So on the right side of my screen, we can see that that test suite has been created. And this is what we're going to use to continually test our code as we continue to make changes and iterations on it. So the rest of the demo will be based on these two pieces of assets here. So we can do first is come over into our command prompt here, and we're simply just going to go ahead and run our tests against that live Stripe sandbox. And as we all know, third-party sandboxes can be flaky. They might not have the data we need. They might not always be available. Can't run load tests against them eventually, right when we're ready to do that. But we can see here that going against the live Stripe endpoint that we have 2 test suites that are currently passing, and then we have 11 tests total that have passed. Now let's go ahead and build a simulated environment for this Stripe endpoint where we're going to incrementally improve on that simulation to add additional data scenarios and allow us to start to add in more of those edge cases, negative scenarios that would be very difficult, if not impossible, to reproduce against the live sandbox. So we're going to do that using our AI agent. So let's go ahead and start a new session here. So we'll see that we're inside of my AI test environments webinar project. And the first thing that we're going to demonstrate is simply creating a simulated Stripe API endpoint using the Open API specification that is published by Stripe itself. So we'll do that simply by asking our LLM to go ahead and import that Open API specification into an existing mock API. So that mock API is 911Q8. Just show you over here, I've got these open, and right now our mock API has nothing inside of it. So we can see there's no stubs inside of here in WireMock Cloud. We come into the Open API, we've got just a rather blank Open API specification. So if we come over and ask our LLM simply to create the mock API based off of that Open API specification, it'll crunch through this for just a handful of seconds here, discover using the WireMock Cloud MCP server, what are the tools that are available in order to push this specification into WireMock Cloud. We can see it's identified that push tool. It's pushing that into WireMock Cloud. And in just another second or two, we'll be able to verify that we've got our mock API up and running in just a handful of seconds here. So let's come over while that's finishing thinking up and come into the stubs here. We can see that absolutely those stubs have now been created. We have our listing of products, listing of prices, and creating a payment intent. And we'll see that, LLMs, as we all know, sometimes take a little bit longer, sometimes they go quicker, but we can see 53 seconds later that we've created a mock API just based off of an Open API specification. And now if I come over and ask our unit tests to run against our mock, we'll watch these tests start to run. We see several of them have passed, but we actually have a handful of failures. Now, this is to be expected at this point. We imported a specification. Specifications don't have a lot of great examples of what a response actually looks like. It's got the general form and the schema, right? But we can see if we just take a look at a lot of these that a lot of the statuses are wrong. So our tests are failing at this point. And again, this is to be expected. Spec-based generation of a mock API is very quick, but it doesn't necessarily describe the full behavior of the API, right? How the data moves and the responses. So let's do better, right? In this next sense, instead of doing this via the Open API specification, because we have access to a sandbox and it is up right now, let's go ahead and just use some recording against that live sandbox to build a mock API. So I'm going to come back over into our LLM over here. We're using Claude Code. I'm going to issue a slightly different prompt here. So I'm going to say, let's actually go ahead and use hold on one second. Yep, this is what I want to do. Let's go ahead and use our tests against a different mock API. So we're going to run that same test suite again, slightly different configuration, because we're going to point it at a new mock API instead of the one we just did the import into. And I'm going to instruct our LLM to actually go ahead and use the live Stripe endpoint when it creates this mock API. This time we're working with GDD07 inside of WireMock Cloud. I've set up a lot of this ahead of time just to make it go a little bit quicker. We don't have to have the existing mock APIs inside of WireMock Cloud. It can create a net new one for you. But just to show you, this is the one. Here's our GDD07. There's no stubs in here just yet. We come to the Open API specification. Again, it's blank. So let's ask our LLM now to actually use the live sandbox and WireMock Cloud in the proxy recorder mode to actually capture the real behavior of this third-party API. So we'll see that it is starting up a recorder. It's going to go ahead and run those tests, passing them against it. We can see that it's actually seeing that it's getting some invalid JSON coming back at the WireMock recorder. So it's going to go ahead and double check a couple things inside of the code. It's decided it's going to use a local proxy recorder instead of recording through WireMock Cloud. That's perfectly okay. So we see that it's starting up a local recorder against port 6408. Now all the tests are coming back successfully, and it's going to go ahead and stop that recording, push it up to WireMock Cloud, and then reconfigure my unit test so that it is where it was before, pointing at WireMock Cloud. So let's double check what happened inside of WireMock Cloud. We can come and look at the stubs now. Again, we're in that GDD07, and now we can see it successfully created the stubs for us inside of WireMock Cloud. And if we come back and now we go ahead and run our unit tests again, this time going against Mach 2, we should see that those are all passing now. So WireMock is successfully taking that recorded traffic. If we come into our request log, we can see all of that traffic as it's occurring. We can see the failed recording that happened at first. And then when we just ran through our unit testing again, we get the success of 200s coming back here. Now, this is great, right? But if we come over into our Open API specification, we want to add some validation into this, those safeguards, making sure that as we add data scenarios into our mock API, remove data scenarios, edit existing data scenarios to add those edge cases and whatnot, that we don't step out of bounds, that we don't start to produce behavior from the mock API that will never exist in production. So we're going to enable this validation mode by simply attaching that Open API spec that we saw that we used earlier during step 1, right? When we generated a mock API from the Open API spec. Well, now we're going to attach that Open API specification to this recorded mock API. And we'll do that from our LLM again. So let's go ahead and issue this command right here. So we're simply just going to push that Open API specification into the mock API that we were just looking at, that GDD one. So if we ask our LLM to go ahead and push that into the mock API configuration, just take a handful of seconds here to complete this. We can see that that's successfully been pushed in 8 seconds. So now if we come back and look at our Open API specification, we'll see that that is completely in there. And my mock API is also set to hard validation mode, meaning that if there is some type of contract validation issue that happens, my consumer pushes a request that doesn't conform to the specification, or the mock API responds back with a response that does not fit the Open API specification, we will get a hard validation error, meaning the response sent back by the mock API will not be anything that looks like a real response. It will be a 4xx or a 5xx error explaining the contract validation issue. So let's come back over and make sure that when we did our recording, and now that we've attached that Open API specification, that our mock API is still conforming to the specification. And we can see that our tests are still passing. Now, just to demonstrate what this might look like, these guardrails with this validation in place, I'm just going to make a small change to a mock API. So remember, these are the ones that were recorded. We know they're good because they were captured against the real API. But what happens if we go and we start creating new data scenarios and we mistakenly make a change to our mock API? All I did was turn an integer, right, or a value, a non-string value into a string value, if you will. If we come back in now and rerun our unit test against mock 2, we'll see that even though they were just passing before, that small change, right? We made a small change in the mock API. Now we've got a whole bunch of failures. And if we kind of just look through some of these failures, we can see, that we've got, different length issues. We've got product IDs that look like they're failing in the assertions from our unit tests that were built by our AI originally. So this is showcasing those validation issues that are happening. That's that validation of the response being sent back. If we come into our request log of WireMock Cloud, we can see a whole bunch of validation issues that were happening. If I click into one of these, we can see this is the actual response that the mock API was sending back, status 500, and this contract validation issue being sent back rather than the originally configured payload. And we can see that it's telling us that a string was found when an integer was expected. So again, these are your guardrails, right? Attaching note of the real service to our simulations gives us those guardrails to prevent false positives and false negatives as we continue to iterate and add additional capabilities into our mock APIs to support our development and our testing. Now, before we get too far, let me go ahead and just return this back to our known good state. And now we should be good to go. We go ahead and run our tests one more time. We should be back to our known good state. 2 passed, 11 passed. Great. So let's take it to the one last final step in this demo today, and that is enhancing. It is really enhancing our simulations to better represent production-like functionality. We recorded just a handful of scenarios inside of our mock API initially. I'm going to take another prompt here. And what we're going to do is we're going to expand the data set that our mock API can actually handle. So we're going to enhance the stubs inside of our mock API using a data source. And that data source is a CSV file that I have inside of my project already. And I'm also going to ask the LLM to, after you make these changes, to turn my simulation into a data-driven simulation backed by a large data set that includes a lot more products than we had inside of our real sandbox inside of Stripe. I want the LLM to go ahead and ensure that all of my tests are passing. Now, this prompt is going to take a little bit longer to run, as it's going to use WireMock Cloud skills and MCP server to take what are static stubs and turn them into dynamic stubs, looking for opportunities to remove anything that's hard coded, be able to read this much larger, more vast product list out of a CSV file into what we call a data source in WireMock Cloud, making those tweaks inside of the stubs itself, where using the handlebar helper library of WireMock Cloud to make sure all of this plumbing works for us automatically. And then at the end, ensuring that our tests are still going to pass after we've now increased the product catalog artificially using these approaches. So we'll see that this is still running here. And while it's running, maybe we can take a question.
Yeah,
So I see one that's, oh, go ahead. Yep.
yeah, no, I was going to help you read out the question.
Perfect.
Yeah, so we have a question from Purnima. In terms of simulation environment, how much can we rely on it to match with the real-time environment in terms of data and event setup available in SB environments?
That's a good question. Tom, I'd love to understand your take on that one.
Yeah, so I think I would say this, first of all, you need to think about your testing case and whether the data matching the real environment really matters that much. I mean, I think there are two distinct things here. There's the structure of the data. So there's essentially the contract that the API implements. And this is something that it's very important to make sure that you match the real API. And this is what Dan's demoing here, essentially. The contract testing element, the validation element of WireMock Cloud is about ensuring parity between these two things. And even as the real API evolves, provided you're regularly bringing, the open API description back into WireMock Cloud, you can use that to ensure that your simulation sort of stays compliant with it. I mean, if it is important to have specific data, in addition to the structural stuff from live, then starting with a recording, so kind of what Dan demoed there is a way of doing that. If you make a recording from a specific environment that has the data in it that you want, then that recording will contain that data. And even when you're enhancing, you can tell your AI tool that I actually want to keep this data. I want it to be a more I want more examples, or I want it to be more generalized, but I still want to get the same results back. Then you can do that. Sorry, I see you've posted a follow up to that. So uh, validation, correctness of data retrieved from the database or any other means would be less reliable. Can you elaborate your question there? Sorry, I'm not entirely clear what you're asking there. Okay. So just while we're waiting for Purnima uh, to type a follow up to the question. Um, I mean, there are a number of ways of working with data in WireMock Cloud. I mean, Dan's touched on these, briefly, and what he's got running at the moment will add statefulness to your simulated API. But there are a few ways you can work with them. So you can have mutable state, which is kind of short-lived. So read and write state, and where a request data can be stored, and then it can be used in later decisions or later responses. And then there's this notion of data sources where you can plug in a relational database or a CSV and use that as kind of read-only data. But both of those can be used. The CSV approach in particular is great if you have the means to extract data from other systems, or if you have a test data management system that you produce test data in, and you want to use that test data in multiple contexts, so not just in your mock API, but maybe your load injector or your some part of your test injector. So there are the tools to do this, and it really depends. I hate to say it depends, but it depends on the where the data is coming from, how much of it there is, and what you're using it for. But there are multiple approaches here.
Great. Thanks, Tom. So we can see that this is just wrapping up here on our flow, asking the LLM to help assist us to add some additional data scenarios, much larger product catalog. And it identified some interesting things that needed to be changed, not just replacing certain pieces, but then mapping different pieces of the request into the response. And the LLM, along with the skill and the MCP tools, we're able to identify these needs, create the data source for us inside of WireMock, identified that there were two stubs that needed to be changed. It even saw that one of them had some limiting, endpoints on top of it, and handled that all for us. So if we come back over into WireMock Cloud and we refresh our mock API, we can now see that we have our database icon referencing that this stub is calling a data source. And if we look at the plumbing that's been put in, we can see that those matching criteria have been built out here. And that dynamic response templating with our handlebar library is doing the LLM did all that heavy lifting for us to fully parameterize these responses based off of that information that now lives inside of a very large CSV file. And if we come back one more time and still run our tests against this endpoint, Remember, this is not only validating that we're getting, two XXs back, but it's also looking at the response payloads, ensuring the prices are the correct prices for the different products that are being listed. We can see that our test suite is still passing. It's also still valid against our open API specification, because remember, in the second part of the demo, we turn on that validation mode, ensuring that any request and response being sent from WireMock Cloud passes that validation so that we have those guardrails and we're not creating those false positives and false negatives. So that's what I wanted to take you through today. I did see that there's another question from Johnny here. And he says, hello, guys. I'm wondering if I understood correctly, can we also simulate a Twilio SMS API, for example? A little bit more to that question there, but that's the gist of it. And the answer is absolutely. In fact, one of the most powerful skills inside of our skill set is the build API simulation skill. So by issuing a command of build API simulation, once you have the skill in place, we can simply ask it to do the Twilio SMS endpoint. And because this is a well-known, well-documented Twilio or third-party API, pretty much this is the only command that we would need to run. And I'll just walk you through what that experience will look like without running the whole thing. We would issue this command here, and then it's going to ask us a couple of questions. Do we want the entire endpoint, or are there just a few paths that we want to? Where do we want to store any local files that are needed during this process? Do you have access to a real sandbox? As I showed you today earlier in the demo, we use the Stripe sandbox to build our initial mock API, run some validations against it, make sure our test suite is appropriate against the live API, so that when we simulate it, then we can run that same test suite against our simulated API. So we're seeing us, walking through all of this. Might need some test credentials. Of course, the skill is going to handle that. We can say no sandbox. And then do we want them to be stateful or not stateful? Statefulness, again, being keeping track of those objects as we mutate them. If we post an SMS message to the Twilio simulation, we need to store that message ID inside of stateful memory so that we can hit another endpoint and retrieve the status of that SMS ID. All things handled automatically from this build API simulation. So again, the answer to that question, right, is yes, absolutely. You can simulate the Twilio SMS API, and it makes it really easy using this skill set inside of our platform here.